from the top. Okay, so we have previously been learning how to name stuff, right? Like, I think I've given the analogy of my daughter before, right? She's learning how to read. And you got to be able to understand your letters, and we got to be able to put them together in words so that you can call stuff, right? So here's the first example I wanted to give. If I gave you this notation here, hopefully you know that, okay, Cu means we're talking about copper, right? And if I asked how many protons it has, hopefully, and you guys did really well on this on that activity, because there was a question on the activity on this. You know, okay, well, there's 29 protons. It's number 29, right? And if I asked you how many neutrons there are, the answer is 31. How did I get that? What did I do? 29 and 31 adds up to 60, the total mass number. Cool. I hope you get that concept, because like you showed me, like I think everybody got that one right on the activity. So hopefully you actually understand that. And let's say I told you that it was a 1+ ion. Well, then I can't have an extra proton. That doesn't make it copper. That makes it zinc. But I could have one less electron, and that would give it a 1+ charge. So that's one skill I hope you have. That would just be like naming and understanding an element. Okay. But elements like to come together and form compounds. Okay. And so there's a couple different types of compounds I hope you know how to name, or at least you're working on, you're building towards this, right? Here's a really good example. Good old NaCl. It's called a binary ionic compound. Na is +1, chlorine is -1, and we literally just call it sodium chloride. Okay, nothing special to it. Name the sodium, name the chlorine, just change it to ide. Okay. But that's where you have one positive, one negative, one anion, one cation, right? Metal and nonmetal. What if I were to give you CO2, where they're both nonmetals? Different naming scheme. And this is the first thing you got to identify is, well, what sort of name do I need to give it? Well, I need to give it its covalent name, which would have been one carbon, so we just call it carbon. And then we have oxygen, so call it oxide. But because there were two oxygens, we call it dioxide. And hypothetically, if there were 4 carbons here, we would have called it tetracarbon dioxide. I'm not actually sure that's a thing, but if it was, that's how we'd name it. Okay, so that's 2. We also learned how to name things that have more than one valence charge. And this is where you have something like iron and, well, let's use chlorine, because this was actually on your activity the other day. And a lot of you guys missed this one, because yes, this is iron, and this is chlorine, which would change to ide. But since iron can either be a +2 or a +3, we have to make sure we use a Roman numeral here to say which iron charge it was. And hopefully you can kind of visualize this. There's 3 chlorines, they're each a -1. Well, then iron better have been the 3 version. I think many of you guys missed that one yesterday, right? But hopefully you learn, right? We're a growth school, this is a growth classroom. Improve, right? Don't make that mistake again. And then the last one is where we're going to build today. It's called a polyatomic. And that's where you might have something like this. It would be like NH4, let's go Cl. We'll use that one. And I know it's polyatomic because there's actually 1, 2, 3 different elements shoved inside of this thing. Hence the name polyatomic. Right? And our goal on this now is to be able to recognize on that little chart that's in the middle of your periodic table, like what's the grouping that we call it, okay? And with experience, and sometimes you just have to really spend some time looking at it, you'll discover that NH4 actually is like it's like a grouping together. It's called an ammonium. And because chlorine ends it, just like all the rest of them, we'd call it a chloride. Okay? But we can do that same thing for one that ends the other way. Like a really typical example would be Na2SO4. Na is sodium. And if you know what an SO4 is, it's called a sulfate. And when it comes to these groupings right here, experience helps. The more practice you have, the more likely you're going to be able to look at it and go, hey, I know that one. Okay? So that's my 5-minute recap of what we've covered so far. You should hopefully have some experience working with elements by themselves, and now we're going to put them together into compounds. Make sense? Today we have to build on that. So I'm going to go back in my slide and now start here. So 4 minutes and 39 seconds later, we're going to talk about something called families of polyatomic anions. And so this is the same idea of those polyatomics. Now, one of the things that maybe some of you guys are already learning is that the periodic table you have in front of you is not everything in the universe. It's a good reference, but it does not have all the information that mankind knows about chemistry, because that would, like, we can't fit that all in there. Does that make sense? And so there are more polyatomics out there than it just lists on your sheet. And they actually fit together in families. And basically it works like this. If you ever have a family, like a polyatomic that ends in the prefix or the suffix -ate, that's your reference point. A great example is chlorate. Okay, this is a chlorate. It's a ClO3, and I don't know why it's 2-, because I'm actually pretty sure chlorate is a 1-. Pretty sure I screwed that one up. Now, the way it works is that these things always end in oxygen. They always end in oxygen. And so you see how I have 3 oxygens sitting on this one right here? Well, what if I had pretty much the exact same thing, but I only had 2 oxygens? It's almost the same thing, but it has a different naming scheme. Rather than calling it a chlorate, if it has 1 less, it's called a chlorite. The way I remember that is it's like chlorate, only it's the light version of it. You know, like eating light mayo. There's like less calories, there's less fat. Well, the light version of it, has 1 less oxygen. Okay. Well, we can actually keep going beyond that. What if you remove another oxygen? This is like extra light mayonnaise that you're having here, right? Well, the way we work this one here is that we call it a hypoite. And I left a blank in the middle of the word because it's now going to be hypochlorite. Because, like, I mean, if it was a chlorate and it then became a chlorite, the chlor is still like what's kind of the root of the word. Now, it's also possible to upgrade this. This would be like, I don't know, rather than it being the light version of something, this is like the extra fatty version of something, I guess, where we're actually upgrading it. We want extra, I don't know, you guys know what I'm saying here, right? If you actually put 1 more oxygen atom into something, you call it a per something ate, like a perchlorate. Okay. Now, many of these are even on your data table. Many of them are there, but some aren't. And so I need you guys to understand how to put them together. Okay. I want to use an example here on another slide. I'm just going to make one up here. We'll make a new slide. We already today talked about something called a sulfate. You guys remember what sulfate was? It was SO4, 2-. Okay. That's our reference point. Now, I believe this one's even in your data booklet. It would be called sulfite. The light version of it, less calories, same great taste. Well, it would just be SO3, 2-. Right? All you do is you drop down an oxygen. Okay. I'm fairly certain that sulfite is actually also in that little table there. It might not be, though. I'm almost dead certain this next one is not. What if I gave you an SO2, 2-? Even though that's not on your table, we should now be able to name it, though. You would call it a hyposulfite. This is like extra, extra light. And hypothetically, I'll put it at the top here. Let's say you ever came across an SO5 with a 2-. Hey, Bill.
Hey, are you guys for 30 seconds?
Can I finish this quick thought here? Okay, this slide here. Okay, so this is now not light at all. This is now the extra fat version. We call this the persulfate. Go ahead, Bill.
All right. Thanks, guys. Just wanted to drop by. We dropped by all the grade classes this morning before you guys were called down to the movie. So this morning you're going to be called down to the media center. We'll be watching called the Indian Horse. What we found yesterday, the reason why we wanted to come by and touch base, the grade 10s and 11s and 12s saw it yesterday. And what we just wanted to give you a bit of a heads up about, it is rated PG-13, but it's very heavy. There's some very heavy. You can imagine the movies about residential school, a survivor from residential school, and all the things that go along with it. So there's those themes in that movie, and all of those things. There, things like physical, emotional, sexual abuse. Those are all themes in the movie. Okay, and what the people yesterday found was it was kind of a punch in the gut by the time they were done. They universally said it was a great movie to see. It is a very good movie, but just we wanted to let you know before you go in that it's really important. It's a very important movie to see, but it's not a popcorn movie. It's not like that. It's one scene Avengers, okay? So just a bit of a heads up, and then there will be time after both Wayne and Bob Martin and Office will be there, and there will be some time after as well. Okay? So we're just dropping by all grade 10 classes this morning to let you know that. Okay? All right? See you later.
Thanks, Bill. It's at 8:30, right?
8:30, yeah, we'll be right around 8:30.
Okay, perfect. Okay. Let's try one more example just to make sure this kind of fits together here. a really common one that you may see would be something like, let's see, NO3 negative. Can you guys look in your data table if you have it nearby and try to figure out what the heck we call an NO3 negative? Ooh, you're fast. Okay. Give everybody else a second here. See whether you can find nitrate in there as well, just to make sure you can see where it was. This is called a nitrate. Okay, so I believe this one here is also listed in your table. What would a nitrite be? NO2. By the way, the charge never changes, okay? That's actually something I should make sure I point out. If the charge was -1, it stays -1 the whole time through there, even when you have the light version of it. If you want to have the extra light version of it, the hyponitrite, this one's not on that table, I bet. Nitrite. I don't believe hyponitrite is listed there, but it's kind of implied that once you get the idea of the rules, you should be able to figure out the pattern. So what would hyponitrite be? No! There we go, we got a laugh. Okay, NO, right, with the negative. Okay, and what if I give you an NO4 with a negative charge? That would be a pernitrate. Okay, so now I've added something new to our list. Okay, now not only do we know how to name some of our elements and a bunch of different types of compounds, we also can add to our knowledge with these things called polyatomic families. Some of them are in that little blurb, that little square inside your periodic table, but some are not. Okay. Questions? Okay, and we'll find practice for this, right? You need to try this once in a while. Okay, moving forward. The main point of today, actually, was to talk about other types of compounds. As we're moving forward, we've already done this in class a little bit. There are things known as either acids, bases, or if it's not an acid or a base and it's like right in the middle, it's neutral. You guys have heard this before, I'm sure, right? So what we want to do as well is talk a little bit about how to define an acid, and we're actually going to talk about how to name acids, because they have very specific names, like sulfuric acid. You wonder, ooh, what's sulfuric acid? What is nitrous acid? Right? So we're going to get to that, hopefully. We'll see what we got in 10 minutes here. Okay. First, I want to describe to you what an acid is. An acid is any substance that when it reacts, it releases a hydrogen ion, which is H right here. And if you go a little further on in chemistry, I'll give you better definitions of it. But the long story short is that an acid, it's probably an acid if it starts with H, hydrogen. Probably. That's actually not a firm rule. There's exceptions. But if it starts with H like this is hydrochloric acid. Okay. And we're going to name those in a few slides. Here's a few properties of acids that maybe you guys know. Acids dissolve in water. They're soluble. Acids should conduct electricity. We did this in class that one day. Acids should cause your litmus paper to turn red. And we don't ever taste them in the lab, but they would actually taste sour if they did. Best example I can give of that, citric acid. Where do we find citric acid? Or oranges, or anything that's like a citrus fruit. Yeah, lemons would be a great example, right? So they taste sour. Okay. Well, the opposite of acids is bases. And bases are anything that produce a hydroxide. If it ends in OH, that is a strong indicator that it's a base. But if you guys take Chem 20 and Chem 30, there is like exceptions to every single rule. So I don't want you guys to say, oh, it ends in OH, it's a base. It probably is, especially right now in grade 10. But like as you learn more, there are exceptions. Bases are usually bitter. They also are usually soluble in water. They usually dissolve. They also conduct electricity. And they'll turn litmus blue, like we did in our lab the other day, our activity. Now, there's actually no special rules for naming bases. And the reason why is that since these things all end in OH, it almost always, if it's a base, is something like this. It is something hydroxide, like sodium hydroxide, or calcium hydroxide, or lithium hydroxide. If you ever hear it end in the word hydroxide, it's a base. Fair enough? Okay. We've actually used these already. How do you tell if something's an acid or a base? You use like something that indicates it. We call them indicators, right? Like litmus, right? Remember how we use that litmus paper? If it's an acid, it turns red. If it's a base, it turns blue. we even use the universal indicator. Remember how I came around and I had a few of you guys try to figure out like what color we thought it was? That's a universal indicator, right? If it's got a low pH, like a pH between 1 to 7, that's an acid. And if it's got a high pH, where it's a pH of like 7 to 14, that'll be a base. Did you guys already know that though? Yeah, I think we covered that in Science 9. So, and that's really what this slide here kind of says. So, yeah. Hey, this isn't actually on a quiz or anything like that, but if in case you're wondering, hey, what does pH stand for? I actually have it up here. pH stands for powers of hydrogen. The reason why we do that is because you'll notice in our acids especially, we talked about how they all involve a hydrogen. Yeah, that's actually where the name came from, in case you're ever wondering where pH came from. So, okay, this is where we're going to finish, and we'll see how far we get. The last thing we're going to add to our list now is how to name acids. That's kind of the main goal of today's lesson. Okay, I gave you a bunch of other like little random information. We actually need to learn and memorize some rules, but they're actually in the data book that we give you. Does anybody have the whole booklet with them by chance, or just the front sheet? Can I grab a copy? Somebody? Here, can I steal yours? Yeah. So inside this booklet right here, they've actually been put inside. Can you guys find like, okay, not the periodic table page, flip to the next one, it's right in the middle, okay? Some of our acid names are in that box in the middle. And I'm going to show you guys how to name acids so you can know like their special naming scheme, okay? So basically I'm going to do a bunch of examples. That's, I think, the best way to learn this is just to show you examples. Let's say that you have HCl, something that is binary. Why is HCl binary? Because there's only one H and one Cl. Like, there's only two things there. Why is HNO3 not binary? Because there's three things there. Why is HClO4 not binary? Because there's three things there. That makes sense. So, if it is binary, here's how we name the acid. Remember how I said it's going to start with hydrogen? Right. So it would have been a hydrogen with something. Well, its name is then hydro something-ic acid. In this case, it's hydrochloric acid. Let's try another example. What if I gave you HF? What would we call that? Hydrofluoric acid. What if I gave you HBr? Hydrobromic acid. My personal favorite? Hi. Hydroiodic acid. Iodic. Yeah. Okay. So those ones are actually pretty straightforward. What you have to remember, though, is that the binary ones get the word hydro at the beginning. Okay. Only, make sure you hear this, guys, only if it is a binary acid does the word hydro come at the beginning. Only if it's binary. Okay. Anything, then, that is not binary, like this one right here that involves a polyatomic, it does not get the word hydro at the beginning, but it may still end in the word ic acid. Okay. Anything that would have ended in ate, like a nitrate, a sulfate, a phosphate, okay, the way it works is that those ones also end in ic acid. So like a nitrate, see how I have hydrogen with nitrate? That becomes nitric acid. Let me do some more examples of this. What if I gave you H2SO4? SO4 is sulfate. That would become, it actually becomes sulfuric acid. Or if I gave you H3BO3. You might not be familiar with this, but BO3 is called a borate. So if you have a borate, it becomes boric acid. Now, that same logic, though, applies. What if we had a perchlorate? You know how we had that per at the beginning of the word that made it like the extra version of something? Well, then all you do is you make it per something-ic acid. So if you had a ClO3, which we know is a perchlorate, call it perchloric acid. Yeah. So like here's a good example. Let's say I give you H2SO5. SO5 is not listed on your table. But remember how SO4 was sulfate? That means that SO5 is persulfate. Okay, so we would call this per, and then sulfur doesn't really sound really nice, so we call it persulfuric acid. You actually have to say like most of the word in sulfur. It doesn't really abbreviate nicely. So this would have been persulfuric acid. Well, there's also rules for the light versions of things. the light versions of things change to OUS acids. So if you had a chlorite, it becomes chlorous acid. I'll do some more examples. Let's say that I gave you HNO2. Okay. H at the beginning, dead giveaway, we're talking about an acid. NO2. Okay. Well, now that we've learned some of our families, NO2 is a nitrite. Okay. Anything that ends in ite becomes an us. So this would become nitrous acid. Or what if it's the extra light version where there's that hypo something, like say this one, ClO, clo. Hypochlorite just becomes hypochlorous acid. That's it. Now, you don't need to memorize these even, because like the basic rules are in your data booklet. Now, there's 5. There's the binary one, which I believe is listed. There's the one where the ate becomes the ick, and there's the one where the ite becomes the us. All you got to memorize is the like extra fat version of per. We'll just put a per in front of it. And if you have the extra light version of hypo, just keep a hypo in front. That's all I got, I think. That's the end of... Oh, I've got some examples here, right? So let's talk through the examples, and then I think that covers our class. So let's try this one, HNO3. I think this is an acid. You know why I think it's an acid, guys? It starts with hydrogen. There we go. Okay, ignore the hydrogen. I don't really care about that then. What the heck's an NO3? It is a nitrate. Well, nitrate becomes nitric. Ta-da! HBr. Not polyatomic, it's binary. Different naming rule. We have to throw hydro in front of it. So it's still an ick acid, but it's hydrobromic acid. If I just gave you bromic acid, that would have come from a bromate, which I believe is BrO3. So if you had like an HBrO3, that would have been bromic acid. But if you have hydrobromic acid, then there's like just HBr. Here's one I've already done, nitrous acid. It came from an ite. So nitrous came from nitrite. What is a nitrite? Well, it's an NO2. Or how about this one, permanganic acid? Okay, I see the per in front and the ick at the end. I know it's coming from a per something 8. Like I'm coming from a permanganate. Now you may not be as familiar with this one here, but you'll have to go look it up. What is a permanganate? Well, if you can find it in your table, a permanganate is MnO4. So that's permanganic acid. What would just good old manganic acid be? What would just regular manganic acid be? Well, it would still be H, and it would be Mn, but rather than being O4, it would be O3. What would manganous acid be? Drop it down one more. Now it would be HMnO2. And if I wanted it to be hypomanganous acid, you just take that one away. That's all I got. So I know I kind of rushed through that a little bit, but I think I covered everything we needed. We now have, give me one more second here before we pack up, because I do want to give you guys a minute to hopefully go to your lockers here. We now have another naming scheme to add to things. So now there are 7 things I need you guys to be able to do. This is my quick summary. Maybe you guys can pack up while I say these, I guess. Okay. Here's the 7 things I need to be able to do. Number 1, can you understand the element notation? That's number 1. 2, oh, never mind, we're getting called down. Okay, go drop off your stuff in the lockers, and then we'll meet you guys in the media center. Okay, we'll do a little review on this tomorrow morning, but we covered what we needed to, so thanks everyone.